developers don't know jack about security. That's a strange thing to hear, right? Strange thing to say. Developers don't know jack about security. Well, that was actually a really famous line at a security conference back in 2011. Developers don't know jack about security. A fellow in the audience by the name of John Wilander had a response to that. His message to the security people was, well, I got news for you. You know jack about development. Yeah. But the problem is that was 7 years ago, and that's still the state we're in now. Us security people know better. We're trying to get people to do things our way, except that doesn't work. Our way of doing things does not fit in with the way the developers do things. Doesn't work. We need to integrate with them well. As we say here in Israel, if Muhammad won't come to the mountain, we need to bring the mountain to Muhammad. We need to bring the security mountain to the developer Muhammads if we want to get things done, and we need them to get things done. We need the developers to do security for us. Because, just recently they put out some statistics. For every 100 developers, there's on average 1 security person. That's not something that we can manage to keep up with. That's a whole lot of code being written and not a lot of security being done. If we want security to get done, we need the developers to do it. So I'm going to jump straight to the end. All right, I'm going to tell you my point. My point is threat modeling is awesome. It's one of the best things you can do to create a secure system. The problem is we can't get it done. Can't get it done for a lot of reasons, and I'll show you why. Because we need developers to do threat modeling. And if we want developers to do the threat modeling with us or for us, well, then we need to make it quick. We need to make it fast. It needs to be easy for them to integrate with their workflow. It needs to be agile. The way to do this is by focusing on business value. That's the value-driven part here. And I'm going to explain what I mean by that. Because if we want to keep doing things the way we've been doing them, keep trying to use the same techniques over and over again without any adaptation, it's just not going to work. We keep doing the same thing. We need to adapt. We need to change the way we're doing it because the way we've been doing it doesn't work. All right, so let me tell you about myself. Here's my details. My name is Douglen. If those of you not familiar with me, that's my face. That's how you get to me. If there's one thing you'd like to know about me, is this, the most important thing. If you want to buy me a drink, I take my whiskey smoky, I need my beer stout, and I need my coffee strong. That's strong. Yeah. The other thing that's less interesting about me is that I'm a software security consultant at a small boutique called Down Security. Development, research, architecture. I also help organize a small conference by the name of AppSecIL. You might have heard of it. That's cool. In addition to that, I'm also community moderator on a site called Security Stack Exchange. Anybody familiar with it? You get a shirt. There we go. You get a shirt. Who else has a profile on Security Stack Exchange? I'm not going to make it there. That was bad. That one flies. There we go. There we go. Come to me afterwards. You'll get some more. Not going to make it to you, Jim. Sorry. Right. I also spent some time mentoring some high school students. It was through Gvaim. Not so much anymore, unfortunately. And as of recently, I'm also the co-founder and co-project leader of the OWASP threat modeling project. It's going to help document some of the stuff that I'm talking about, and we'll talk more about that later. All right, make sure you come to me, get shirts afterwards. Okay, so I've been talking about threat modeling. Who here knows what threat modeling is? Who's heard of threat modeling? Okay, those of you don't know what threat modeling is, I'll explain in a moment. Those of you who aren't familiar with threat modeling, pay attention because I'm about to change your view about what threat modeling is. So generally speaking, threat modeling is, call it a methodology, call it a framework, call it an approach, whatever you want to call it. The point is to do security-based analysis for your software design. Okay, there's a lot of different methodologies, a lot of different approaches to do this. The point is to understand, based on the design of your system, understand the different parts of it. You review that, and you're able to understand where the attacks come from, what threats could possibly affect your system. The reason we do this is to be able to prioritize these threats. You fix the most important thing first, and the less important things later, hopefully, eventually. But you know what? We can't really fix everything, okay? The not important things we won't ever get to do. And you understand what's important and not important by threat modeling. Okay, so classically speaking, when we're talking about threat modeling, usually you focus on the data flows. You know, diagrams are great for this, data flow diagrams, process diagrams, whatever kind of visual aid you have. It's really easy to break that down and understand the parts of the system and understand how that affects and what threats can get into which part of the system. Maybe you're focusing on assets, database, files, where the money at, all that stuff, trust boundaries. It's usually a 4-step process, generally speaking, with a pre-step of everybody sitting down in the same room and agreeing what part of the system we're scoping right now, what the threat model, which part of the threat model we're including right now, part of the system. Step number 1 is decompose the application, understand the different elements, the different components of the system, how they interact, where the flows are. Based on that, we can then identify the threats using different techniques, and I'll show you in a moment. And based on that, you understand the risk level, how important they are, because you understand what it actually does. After that, it's pretty easy usually to define how you fix these things. I'm shiny. It's pretty easy to understand how to fix these things, how to apply the countermeasures. And then, of course, you want to review what you did, review the threat model. Did you find all the threats? Did you analyze them properly? Did you fix the threats? Did you fix the right threats? Did you introduce any new threats? Is there any residual risk? This is the basic general 4-step process that you'll usually apply to build the threat model. The output of this, of course, is usually some diagrams, data flows, and a long list of possible threats with security documentation, what you're fixing, what you're not, why, how you're fixing it, and so on. A lot of documentation. For those not familiar with it, this is a typical, a basic data flow diagram, a DFD. So you have over here, let's see if this works. Yeah. You have over here a process, you have different databases, you have flows over here. And of course, over here, you have the external user who could potentially be an attacker. You have the data flows returning and the data flow coming in, crossing a trust boundary. So of course, that one's red, that one's going to get the most attention first, because obviously that's the most dangerous element here. The other ones are also interesting. We're also going to have to model those, but usually that's where most of the dangerous attacks will be coming from, at least to start with. Now, there's a lot of different methodologies. Probably the most common, most well-known one is called the STRIDE, or STRIDE by element, also known sometimes as the Microsoft model. There's attack trees, which are a great tool I'll explain in a moment. There's asset-focused, software-focused, attacker-focused, risk-based threat modeling, which is a whole nother level of really in-depth assurance, which is really interesting. I'll mention that in a moment. Let's start with STRIDE. STRIDE is an acronym. Very important to take into account, this is not a categorization. This is a mnemonic. It's helping you kickstart your brainstorming, kickstart your juices to understand, to try and imagine what could possibly be the attacker goals. These are technical goals of the attacker of attacking your system. So S, we have spoofing, pretending to be somebody you're not. Tampering, changing data you shouldn't have access to. Repudiation, claiming you didn't do something that you did. For example, telling the bank you didn't approve of a certain transfer. Information disclosure, getting access to data you shouldn't have access to. Denial of service, blocking access to those that should have access. And elevation of privileges, basically doing anything you're not supposed to do in the system. Again, it's not a categorization. It's helped you to try and brainstorm what could possibly be the attacker's motives when he's trying to break into the system. Basic, very common. There's a few other methodologies we'll look in a moment. Let's see how STRIDE by element actually works. So we take this DFD and we say, okay, let's take this element right now. You have a browser sending HTTP request over to web server. Are there spoofing threats here? Well, it's HTTPS, so there still might be some spoofing threats. Maybe the user isn't who he claims to be. The server might be SSL spoofing, SSL man in the middle. So there's some interesting threats here. Tampering, probably not directly without the spoofing. And so on. Information of disclosure, well, we're sending data back to the user's browser. And you break down for each one of these elements, you go through the list and you ask the question, what are those spoofing threats? What are those tampering threats? What could possibly be a goal for the attacker on that element? And you can also do this in the back end. So we have here a messaging bus, like a messaging queue, for example, and we ask the same questions. Can I spoof this? Usually yes, because there's usually no SSL on that. So I can usually spoof sending messages to the message bus, right? I could spoof also the client of the message bus, send fake messages. I could usually tamper with those messages. I could erase those messages, I could change those. And for each one of these components, each one of these elements, we go and ask each one of those questions on the STRIDE. That's how you do STRIDE. Very basic, very simple. It's pretty easy to understand. To be able to actually do this, it's usually a lot more involved. You could do this also on other kinds of diagrams. If you don't have a DFD, you could use a process diagram, which is kind of the same thing, just more of a logical perspective, and do the same thing for each component here. You ask the stride questions. Another interesting tool is attack trees. Attack trees put the attacker, the end actual goal up here. For example, the attacker wants to read the messages, and then the branches here are different vectors to achieve that goal. For example, SQL injection, you have over here, users not logged off, bypassing authentication, and there's a few different vectors. So for each vector, you want to have a leaf of a control against that vector. And then it's pretty easy. Based on this tree, you see here, oh, hang on a second, there's a vector here that's not mitigated, which means that the attacker can get through this way to get to that goal. So attack trees are really powerful, but a lot of work. Again, they help flesh out a lot of the details sometimes, but usually not often worth the trouble. Another really interesting thing is a risk-based threat modeling methodology called PASTA, Process for Attack Simulation and Threat Analysis. This is a very involved method, but it gives really good assurance. You really know that you're finding the right threats based on statistics and threat intel and a whole lot of other stuff. It takes that 4-step process that we've talked about before, and it breaks it down in a lot more detail into 7 steps. Okay? It's basically the same thing, logically speaking, just goes into a lot more depth on each level. This gives you really, really good, on paper, very good information of how great your threat model is. And that's really great for a security team because you know you found all the threats and you're fixing the right threats and you can really prioritize based on data. And that's great. Everybody loves data. So it's really good for the security team. Fantastic for the chief security officer. It's amazing for the chief risk officer. You know what's not so good for? Not so good for the developers. It doesn't work with the development process. Let's look at what we just talked about. It doesn't matter which methodology we used. Let's talk about the threat modeling process from the developer perspective. Remember, it's the developers that are building the software systems. You can't do the threat model without them. I mean, you could do it, shelfware, go ahead and ignore it. But if you want it to actually have an effect, you need to involve the developers. And the developers don't like being involved in this kind of process for a few reasons. Number one, it takes a lot of time, right? You can send it away to a consultant for 3 weeks or have an internal team work on this for 2 months, you know, and they'll come back and it's great. But, you know, who's got time for that? Number two, and I'm sorry for Tanya, she's not in the room, but security is not everybody's job. The programmer's job is to write code. It's to produce features, right? To make business value, whatever those features are. Okay? It's a responsibility, sure, they need to take care of security, but that's not their job. They've got 8 bosses, Bob, 8. Do you really want to be number 9, tell them, oh, security is also your job? That's why so many developers hate us. Think like an attacker is particularly insidious. Think like an attacker. Try and understand what the attacks are that he's going to do. Nobody's been trained to think like an attacker. It's like if I were to say, quick, everybody, think like a chef. Nobody knows what that means to think like a chef. Does that help me cook better? I mean, thinking like a chef, that doesn't work. On the same way, let's say I did think like an attacker. Well, what does he want? He wants your money, that's it. There's no really extra point to modeling things, right? Threat modeling uses a lot of details. It likes a good spec, right? Use cases, detailed specification, technical spec, except that most developers don't work that way anymore. They use a lightweight spec, using the user story with a minimal amount of detail, just-in-time design, not a lot. So it doesn't really work when you're trying to build a threat model based on a design that you don't actually have all the details for. And the same way, Agile says no big design up front. If you don't have a big design, you can't do a big model up front. We talked about threat modeling, documenting all the security documentation, and that's great. You have it all in one place. But when you're reading the actual documentation, the actual design, why do you make these choices? Oh, that's separate. You go look at the security design. That's in a different place. That security team has their own wiki for that. And in the same way, because it's separate, very often, by the time you get the threat model, well, that's fine. We're good. We already changed the design. That's not relevant anymore. Or we got rid of that feature. So why bother? The great thing about threat modeling is that you don't waste time fixing things that you don't need to. But you're still wasting a lot of time modeling all these unimportant threats. So again, now developer teams, like, they're in the sprint, they're running, they're building features. And as security people, we like to tear things apart. That creates conflict. That's friction. These teams don't work good together, according to this. And of course, based on the issues that I mentioned before, you have this one person in the security team for every 100 developers. They're coming and going. Every 2 months, the security guy comes in and is like, everybody stop what you're doing, roll it back, tell me what you've been doing for the past few weeks, explain to me like I'm a child. We've been working for 2 months, leave us alone, what do you want? And of course, obviously, security teams don't have an army of drones. We wish. One security person for every 100 developers. We can't keep up. So quite justifiably, the response of the developers are, yes, we want to do the right thing. I'm really right there with you. But yeah, tell me when you're on my speed. Tell me when you catch up with me. And us security people are stuck holding our shovels, trying to catch up, but using the wrong tools for the job. We're spending a whole lot of effort and not getting anywhere. So, what do I suggest? Let's take it back. Right, the 4 steps that I was talking about, the 4 steps of threat modeling, can actually be translated to these 4 questions. Adam Shostak, who quite literally wrote the book on threat modeling, by many he's considered to be the father of modern threat modeling. He defines threat modeling as the answers to these 4 questions. Number 1, what are we building? That's the application decomposition. This is your system design, the DFD. What can go wrong? These are the threats. What are you going to do about it? That's the countermeasures, right? And did we do a good job? Did we find all the threats? Did we analyze them correctly? Is there any residual risk after we mitigated them? Right? Did we introduce any new risks? Did we do a good job? Okay. So that's basically the threat modeling. Now, Adam Shostak also says one other thing very often. Anytime we're talking about threat modeling, he likes to quote George Box with this comment. And I like to misquote Adam. So if there's one thing you take away from this talk, it's this. All threat models are wrong. Some are useful. All threat models are wrong, some are useful. Okay? Take that into account. All our methodologies that we're talking about are trying to get a better threat model. More complete, more detailed, more assurance, more data. That's what we're talking about. But all threat models are wrong, so you cannot make the perfect threat model. But you can make sure that it's useful. So what do I say? Lean into it. Grab that with both hands. Make it as wrong as possible. Make your threat model wrong as long as it's useful. Optimize for usefulness. I don't care how wrong the threat model is, as long as you're building more secure features. If it gets the user stories to include security, if it gets the features developed to include secure concepts, that's what I care about. Even if the threat model is completely wrong. Accept that it's wrong, focus on the usefulness. All threat models are wrong. So, told you what's wrong. What's right? How can we build this? I'm going to take those 4 questions and rephrase them in the following 3 questions. It's basically the same thing. Number 1, why are we building this? Not what are you building. Developers know what they're building. They don't need to tell us. They know it all. Why are we building this? What is the goal of this feature? Why did this one get through product management? Why are we developing this one? Why did this one get pulled off the backlog before those other features over there? What do I get out of it? The business, obviously. What needs to go right in order to achieve that value? We know what our goal is. We know our value. Certain things need to happen in this feature in order to achieve that goal, in order to get that value. What needs to go right, and how do we ensure that that happens? Whatever that flow is, whatever those conditions are, know what they are. How do you fix that? How do we ensure that that happens? Now, these are really basically the same 4 questions, pivoted on a very important concept. Before I tell you what that concept is, I need to give you a warning. The next slide is a little bit shocking. Okay, prepare yourself, especially security people. The next slide explains that simple concept that we change the questions on. Leave your FUD at home. We don't need it. Send your snuck to Chicago. We got enough of that. We're building stuff here. We don't have time for all this negativity. Don't focus on the threats. Focus on the business value. How do we build stuff in a better way? Now, this is kind of part of the divide between security people and developers. Developers build stuff. Security people know everything's broken. Well, that's great. Developers know everything's broken anyway. We're still building. We're still going ahead. We're still going forward. Now, interestingly enough, just very recently, just a few weeks ago, I saw an argument on Twitter. Got kind of nasty towards the end. But somebody pointed out something very interesting. Rob pointed out that when they're talking about in aviation controls and aviation safety, they're always talking about safe transportation. They're not talking about preventing crashes. Okay? They're not talking about stopping the next hack. They're talking about safe transportation, safety. Okay? In the same way, focus on how to build secure features and not how to stop hacks. Quite coincidentally, this pretty much matches Simon Sinek's Find Your Why. Anybody familiar with Simon Sinek? Well-known motivational speaker. He says everybody knows what they're doing. Some companies know how they're doing it, know the right way of how to do what they're doing. But if you really want to make progress, you need to understand why. If you want everybody to be on the same page as you, you need to align their incentives. You need to understand why we're building these features. Because you want the developers to integrate the threat modeling into their process. And the only way you can do that is if your incentives for threat modeling align with their incentives of building features. All right, so let's talk about actually how to do it. Gave you a lot of approach, a lot of upbeat, rah, rah, rah. Okay, good. We're going to do things positively. Great. Let's talk about how we do it. It's not working. There we go. So number one, we start from a standard baseline. Not every time we build a threat model, we need to start building up the entire architecture. We're talking about a basic website. You don't need to start threat modeling the entire architecture. There's a lot of basic things that you can automatically use. You don't need to send it away for 3 weeks to a security team to come back and say, oh, you know what? You're going to have XSS threats. I know we have XSS threats. Everybody heard Jim. Of course you have XSS threats in a website. You don't need to threat model XSS threats, right? You don't need to send it away to an expensive security consulting company. Sorry, Josh. You don't need to send it away to an expensive consulting company, come back 2 months later and say, oh, you better put HTTPS on those endpoints. I know you need to put HTTPS on those endpoints. You don't need a threat model for that. That's the basic. That's the basic level of code hygiene. And if your developers don't know that, well, yesterday we had a great day of training. That's what they need. Security training, start from basic level of code hygiene. These are the basics. We don't need to threat model those things. Okay? The other thing that's, there you go. Training, yeah. The other thing that we need is a nice threat library. There's a lot of default things. Yeah, XSS, that's a great example. You don't need to threat model that. That's automatic. You have a website, plug in XSS as a threat, plug in the XSS countermeasures. A good threat library, and there's a few products out there that provide this automatically. There's a few other things that you can do to build your own. The OWASP threat model project is going, part of what the documentation is doing is to eventually provide that threat library. There's a lot of default considered things, and you don't need to waste time threat modeling those things because everybody knows it. It's out of the box. Next thing we do, so if we talk about what we need to skip. Now we start for each user story or epic or feature. Whenever you're doing your discovery, right? You do the minimal, just-in-time design. That level of design that you put into the user story, that's where you put the threat model. You have just enough design on that user story, just enough threat model, minimally viable threat model. And that's okay because it's going to be incremental and iterative, and we're going to come back to that on the next one anyway. But for this user story, for this feature, we're going to put just enough threat model into that. How do we do that? You start by finding the value. You focus on the value. Usually, it's something like follow the money. Sometimes, it's how do people die. If you're building a train system or an airline or a hospital, right? Find whatever the value of that feature is. Why you're building that feature, there's always some value to the business. Some business goal is going to be achieved by this feature. Otherwise, why bother wasting time on it? And you know what? Yes, sometimes when you ask that question, they'll say, oh, well, you're right. We don't need to build that. Scratch it. Save some time. Excellent. Threat modeling is starting to save time instead of wasting time. So you find the value. Follow the money. How do people die? So for each user story, you're going to understand why we're building it. What are the goals that we're trying to achieve with this user story? What's the flow that needs to happen? The user flow, the data flow, whatever needs to happen. What are the conditions? What happens when those conditions aren't full? When they're not filled, there's some failure state. That needs to be explicitly defined. Now, usually, the developers know that, or the architect kind of knows that. It's not always well defined. It usually just kind of sort of happens. There's assumptions, there's conditions. Explicitly validate that, and you're golden. Because what we're trying to do with threat modeling, with the whole secure development, is to protect the value you achieve from a certain feature. And that's it. You're gold. If you can ensure the value you're trying to achieve is achieved, you don't need anything else. Don't worry about threats. Worry about protecting the value of the business. Now, I have a few minutes. I'm going to show you a really quick example of how to do this for a specific feature. I'm going to show you my favorite website, OWASP Juice Shop. Anybody familiar with that? Juice Shop? Excellent. It's the best place to order juice online that will never show up. It's basically a broken web app to show you how things could be broken, it could be attacked. And this is about all the level of architecture we need at this point, understand where the pieces are. And then you go look at the feature. Okay, so we're shopping, we choose our juice, and we get to checkout. And you know what? Product marketing comes to us and says, you know what? I want to start running some specials every couple months. I'll do a sale, 30% off, give us a code for everybody, right? Find it on Twitter, get a code, 30% off. Great. Now you could just go ahead and start, running and start coding that. Or you could try build a threat model. What is the threat model of this feature? Where's the data flows? You say, stop. Why are we building this? What's the point of this sale that we're doing? What's the point? Anybody? Money, but more specifically. We want more people to know we want more customers. So, marketing might say, you know what? Run a sale like this, run it for 2 weeks, you'll get a 35% uptick. Great. Of those, 10% will be recurring customers, and they'll stay on. So we might lose a little bit of money on the sale, but we make it up on the recurring customers that next week will keep coming back and paying full price. Okay, so we understand the value. Customers, recurring customers. So now we can ask, well, we have here the sale, right? So it's supposed to run only till July. Wait, can I continue using this indefinitely? As a recurring customer, can I use this always? The point is I want them to pay full price, right? Can I use it always? Can I, instead of 30%, where's the 30%? Instead of 30%, can I get 60% off? Ooh, starting to lose more money than I expected. 90%? Can I get it for free forever? Can I do it minus? And then the competitor will make me use this, and people will start getting really pissed off at me, and I'll lose business because of that. Focus on the value flow. New customers. That's what we're trying to generate here. That's just a really quick. So while defining this feature, the user story, ask those questions. And then you can understand, okay, this is what we need to protect. This is the flow that we need to protect. Let me give you some quick tools. I have a few minutes. Some quick tools to use to integrate this into the user story definition, part of the agile development. Number one, when you define the user story, one of the things that you can define is acceptance criteria. This user story is not complete until, for a login mechanism, when I log in with the wrong password, I should be locked out after X times. Put that in as an acceptance criteria. After you understand what the value there is, you put that in as acceptance criteria into the user story. And that's great. You can also define globally definition of done. User story is not properly defined, and no developers can start working on it until I have the acceptance criteria as part of the threat model. Once I have this threat model, minimal threat model, these acceptance criteria, I can go ahead and continue with security unit tests. You're building unit tests based on those acceptance criteria. Build security unit tests based on the security criteria. For example, test that user accounts are locked out after X attempts. And of course, the corollary for that is that they're unlocked after Y amount of time, right? Because otherwise you realize they get locked out, and that's part of the value flow here. Part of defining user stories, you could also define abuser stories, right? Talk about the attacker's perspective, except most of the people that have experience with abuser stories don't like using them because it doesn't feel right. It doesn't work out good. It doesn't provide a lot of value. I find that they're a lot more valuable when you focus on the value-driven part here. How does this affect my value? Not the attacker's perspective, not what he wants to achieve, but how this affects my value chain. For example, as an attacker, I want to impersonate another user so I could steal their juice box. Not so that I get other things. It's the juice box. That's already going to affect me. This is my juice store. I'm selling juice. I don't want people to steal my juice. Right? This is my value chain here. Everybody's familiar with the agile user story format as a I want so that Recently, a few months ago at the Open Security Summit in London, after a bunch of conversation with a lot of brilliant people, they came up with a slightly updated format with another clause, without. As a customer, I want to complete a purchase so that I can get juice delivered on time when I need it, without my credit card being stolen. Now, there's not a lot of detail there, but that's okay. User stories don't have a lot of detail. A user story, anybody define user stories here? Agile user stories? It's an invitation to a conversation, right? And based on the as a, I develop additional details, such as the acceptance criteria, based on that invitation. So if all I need to do is put in that little cue of without my credit card being stolen, that focuses on the value chain here for the user, then you can develop that conversation around other security aspects. If anybody does get to implement this came up relatively recently, I'd love to hear how that goes. I heard some feedback on that so far. It's been really great. Another thing I like to use is called the threat pyramid. Everybody familiar with the food pyramid that they used to have? Certain amount of grains, certain amount of fruit, vegetables, protein, etc. You need just enough, but not too much because that's not too healthy, right? Or I'm sure you're more familiar with the Maslow's hierarchy of needs. There's no point talking about self-esteem and love before you're physically safe and your physiological needs are taken care of. In the same way, we can apply this just to threats, right? For example, there's no point worrying about user access issues or denial of service if I have a whole bunch of remote code execution going on, okay? So when I'm relatively certain that I've dealt with all these threats, I can start moving up the value chain and understand the more interesting things. But we can take this further. These are all basic technical threats. Now, usually what happens is I spend half my time in SQL injection XSS, whole bunch of time enforcing weak passwords. Yes, I heard what I said. And a whole bunch of money throwing at spam and antivirus. Why? Why not? But we could take this further and apply it to value-driven. Okay? What are my values? Number one, money, right? You said money. If somebody can access the shop's bank account, that's pretty much the most important thing. If there's any flow there that lets somebody access my bank account, start with that. When I'm relatively certain that that's safe, I can start looking at credit cards. One credit card, not a big deal. A whole lot of credit cards are. Start looking at that. Same thing with PII. That's a whole lot of money nowadays. Threats around that. And then I get to the really interesting threats that are based on my value. Lost market share, stolen juice. Now, I'm not going to deal with stolen juice when everybody can access my bank account directly. Another thing I like to use relatively recently, I discovered this accidentally. Familiar with story points, kind of a rough estimate of how much effort I need to apply to build this user story. Usually they use rough numbers, like relative numbers, like t-shirt sizes. Small amount of effort, medium amount of effort, large amount of effort. Break this down further. And there's someone who was talking to me about story points. And, well, I was in artillery, so I misheard him say, story points. I'm like, ooh, that sounds really interesting. Tell me more about story points. He had no idea what I was talking about because I'm the only deaf one. But it actually created a really interesting conversation. Story points help us understand how much threat model effort I need to put into something. For example, if this user story that I'm building blows up in my face, everything goes sideways, everything blows up in my face, are we talking about a few extra overtime hours to fix it? Or do we need to call the CDC, right? Are we talking about a few scratches on my face, or am I stuck stranded on a beach with a couple of pythons eating themselves while a shark-eating dingo looks on? How bad could this be? And based on that, I can know, well, yeah, not too bad. I can just spend a few minutes understanding what I need to do with it. Or maybe I need to call in the experts to come do the full-size threat modeling. Maybe I do need pasta. Maybe Stride is good enough. Or maybe I could handle this myself. How bad can things go wrong? The other thing I get out of this approach to value-driven threat modeling is that your communication about the threats becomes a hell of a lot more powerful. For example, Jim did an excellent explanation yesterday of CSRF, cross-site request forgery. I'm sure everybody there understood it. They're then going to go back and tell their product owner or their development manager, oh, we have a CSRF threat in our system. And it's like, oh, that's really interesting. But let me ask you something more important. What do you think they're serving for pie today? Well, yeah, so that doesn't really get anything. But if you say, oh, unauthenticated access to cash transfer, that's going to get attention. That's going to get fixed. In the same way, stored XSS is great. Everybody knows about it. Yeah, well, sure, we'll fix it. But I can use stored XSS to do an admin takeover of your system. That's spending time on it. Same thing with other kinds of technical threats can be explained how this affects the bottom line of the business. Where's the value at? Okay, changing delivery address, all of a sudden Amazon's shipping things all over the place to the wrong address. They care about that. Denial of service, loss of revenue market, that's going to get some actual hours spent on that. We can use the same approach also for black box threat modeling, for a pen test. When was the last time you got a pen test that actually said about things that the business really cares about? A value-driven approach instead of just technical attacks and threats. It's good for communication. Now, what do we get out of all this? Well, number one, it's a lot faster to get actual value. Yes, it's not complete, but you get actual value. It's more useful right away. Because as soon as you have user story, you have your threat model. You're building a more secure feature. That's what we care about. That's what's important. That's how you get more secure features. It's useful. Because it's part of the development process. Same pace. It's iterative, same process like Agile. They're used to that. It's part of the development. And it's more natural for them to work that way. And not stop and wait for the developer to show up 2 months later, wait for the security team to show up 2 months later with their big whole set of Excel sheets instead of their user stories in Jira, whatever. Documentation is up to date because it's part of the system design. It's not a whole separate security documentation. Helps communicate better, integrates better with the existing Agile processes, Scrum, it's right there, Kanban, you can plug that into the card, not an issue. Perhaps most importantly, you don't need to pay a whole lot of money to all these expensive consultants to do the threat modeling for you because you just do it part of that. And it is scalable. You don't need to wait for that one security person to get around to 100 developers because they're doing it themselves. So I told you what's good. Let me tell you what's bad. It's not complete. It's wrong. That's fine. That's part of it. That's built in. It's kind of by definition. But if you need high assurance, if you're building, let's say, a defense system, a military system, it's probably not going to work for you. If you're building a banking system to protect billions of dollars, you're probably not going to be enough with it. Sure, start with this. Start with the value-driven approach. But it's probably not going to be enough, and you're going to want to get later to a higher assurance methodology. You need to assume that your developers kind of know what they're doing, so it helps to have a security champion, which is basically developer with another hat on, spend some time pushing the threat modeling along, and it's low assurance. Again, very risky systems, probably not enough. You'll be able to discover that using the sorry points, which helps you realize when you need a higher assurance methodology. But it's not enough. So let me sum up. And if there's one thing you take away from my talk, it should be this. Shut up, not the other thing I said before. This is the most important thing. Just start doing it. I want developers, everybody needs to be threat modeling as part of their process. That's all you need, just start. It will be wrong, that's fine. The first time you do it, it will be completely wrong, that's built in. Second time, maybe a little bit less wrong. Third time, it will actually be useful, and you'll know what you're doing. And because it is part of the user stories, you're going very fast. Every sprint, you're doing this a couple of times. So that's great. So you'll get to useful a whole lot faster by focusing on business value. Don't be purist and show me every possible threat. Show me what I care about. Show me what affects the business bottom line. Start with the most useful part. Don't go anywhere until you actually need something else. That's all. Thank you very much. I have 4 minutes for questions. Any questions? Fellow in the back. Well, I don't necessarily focus on the technical risk, right? You're building the feature. Yes, I call this threat modeling, and I'm not talking about the threats themselves. I'm talking about the value. I'm inverting this to some extent. Where are the threats? The opposite. Yeah, it's what can go wrong, but I'm talking about what I need to go right. And yeah, there's going to be a lot of technical risks. XSS, fine, SQL injection. Those are technical risks that should come straight out of your threat library. You don't need to spend time threat modeling that because you know it. There'll be a few that are a little bit more involved, and that will usually come out from the sorry points. And just because we're doing this lightweight, minimally viable, just-in-time threat modeling as part of these user stories, that doesn't mean you can't still have somebody do this out of band, a full-size threat model. Sure, do it out of band if that's what you feel you need. Meanwhile, developers are going forward, building secure features. You come back, find some obscure threat, that's fantastic. Meanwhile, everything else is protecting the value. Yes? Because it's not focusing on the threats, it's focusing on the value that you're building, right? You define the feature, the feature that you're building as part of the value that you want to protect, right? That's what it's doing. So basically what you're saying is what you define that you're doing, just make sure you're doing that right. You define that there's certain conditions for this feature to happen, enforce those conditions. Be explicit about conditions. Be explicit about your assumptions, enforce those. That's pretty much it. It's really not like a whole long threat modeling process. It's not focusing on the threats, it's focusing on what needs to go right, which they kind of sort of know anyway, they're just not being necessarily explicit about it. Does that answer your question? Anything else? All right, let's do a quick selfie. Here we go. Here we go. Anybody that doesn't want, take a second, close your eyes. Close your eyes. Put your head down, I'll close my eyes. Everybody, say, ah. End of the day, everybody's hot. Say, it's too damn hot for this stuff. There we go.
Give a round of applause for Avi, please.
Yeah, thank you very much.